So then what about those problems that did require rewrite? So what if I had f of x equals 1 over x cubed? Okay, so from what we did earlier, in order to shift the x up, I get x to the negative third power. So then f prime of x equals, there's an invisible 1 in front of that. So pull the 1 out and bring the negative 3 down, multiply by that, and then we'll do negative 3 minus 1. Alright, so 1 times negative 3 gives me negative 3. X to the negative 3 minus 1 gives me negative 4. Okay, so when you subtract from a negative, you get more negative. Okay, unfortunately for you guys, I'm going to require you to rewrite these so that there's no negative and no fractional powers. So it's kind of convenient to have your numbers as a fraction. The rewrite on this is negative 3 goes in the numerator, there's 1 in the denominator, and you should be able to see that this x is going to be in the denominator because it has a negative power. So then your derivative f prime of x equals negative 3 over x to the 4th power. Another example, you had g of x equals 1 over x to the 9th power. Okay, the rewrite on this is x to the negative 9th power. Okay, so that's just a rewrite. G prime of x. Okay, there is a 1 in front of. So 1 times negative 9, x to the negative 9 minus 1, which equals negative 9 x to the 10th power. Correction, negative 10th power. Let's put the negative 9 over 1. So then g prime of x equals negative 9 in the numerator, 1 in the denominator, and again the x is raised to the negative power. We would expect that to be in the denominator. So this is negative 9 over x to the 10th power. Okay, so let's move on to the ones that require a radical. So what would happen if you're given k of x equals the cube root of x to the 4th power? Okay, so if you remember from the earlier video, you should be able to take your root and it'll sit right underneath your power to which the x was raised. So this equals x to the 4 over 3. So then k prime of x equals, there's a 1 right there. So 1 times 4/3 x to the 4/3 minus 1. Like that. So you might want to do this in your calculator, it might be easier. Do 4/3 in your calculator. I can show you that. If you do 4/3 minus 1 in your calculator, then you should be able to press the math button that's on your left of your calculator, and it should be able to allow you to convert it to a fraction, FRAC, right? So that's what I typically do. So then k prime of x equals 4 over 3 x to the 1 over 3. All right? So as I mentioned, I'm not going to allow you to leave this as fractional power. This is positive 1 over 3, so the x should end up in the numerator. Okay, so this should be 4 in the numerator, 3 in the denominator. I'm going to force you to go back and write it as a root. And the fast way to remember it is whatever root you started off with, you ended up with the cube root, you should end up with as well. So this is the cube root of x to the 1st power. And you can always check that, right? So you can always let the 3 travel around and sit underneath the 1, and that's how you're getting the x to the 1/3. Alright, so let's try another one that might be a little bit more complicated even than that. What would happen if we had z of x equals 5 over x to the 6th power. All right, so as I mentioned in the earlier video, there's a 1 in here that's invisible. So this is 5 over 1, x to the negative 6th power. So then z prime of x will equal 5 over 1 times negative 6, x to the negative 6 minus 1. Notice I'm doing the same 2 steps. Bring the power down, 1 less power. Okay, so in order to multiply 2 fractions together, it's kind of helpful to have them both in fraction form. So I'm going to make this negative 6 over 1. And then you're just multiplying the numerators together and multiplying the denominators together. So this is negative 30 over 1, x to the negative 7. Okay, you'll notice that there is a negative power here. So you could rewrite this as negative 30 over 1 times x to the 7th power. Okay, so we're almost there. So we can say that our slope generating machine, or our instantaneous rate of change, is negative 30 over x to the 7th power. Alright, so another example is what would happen if you had f of x equals 3 over 7 x to the 9th power. Okay, as I mentioned, you should be keeping the numbers together. So there's 3/7, and you can rewrite that x to the 9th in the denominator if you want to bring it up to your numerator, and you should, because your numerator has to be in the your x has to be in the numerator in order for you to do the power rule. So now when you do the derivative, f prime of x equals 3 over 7, pull that out. Negative 9x to the negative 9 minus 1. Same 2 steps. Pull the power down, 1 less power. All right, I like to multiply these 2 together, but they're not both fractions. Not too bad. Make that negative 9 over 1. So then f prime of x equals negative 27 over 7 x to the negative 10th power. All right, I'm going to keep going. So this equals negative 27 is in the numerator, 7 is in the denominator, and now this x to the 10th should be in the denominator because it has a negative power. So please keep that in mind. All right, what about this? G of x equals 1 over 8 x to the 4th power. I think I did 14th in your notes. All right, let's rewrite this. Leave the numbers alone. So this is 1 over 8 x to the negative 14th power. So then your derivative, same 2 steps, right? Pull out the 1/8 and pull down the power, x to the negative 14 minus 1. So then your derivative, or your instantaneous rate of change, I'm going to put this over 1 so I can multiply straight across negative 14 and also straight across here over 8 x to the negative 15th power. Okay, of course you can simplify 14 over 8 as a 7 over 4 if you so desire. But the final rewrite is negative 7 over 4. And this chunk is going to go down in the basement as x to the 15th. Alright, so I only have 3 more that I would like to go over. And they deal with rational power. So let me just do the most complicated one. So say we have k of x equals 6 over 13 7th root of x squared. Okay, let's rewrite this as 6 over 13 x to the 2 over 7. Notice this 2 is going to come around and sit right underneath the x. I'm sorry, underneath the 7 will come around and sit underneath the 2. So then k prime of x then equals, I'll pull this 6/13 to the front, 6/13, x to the negative 2/7. Notice I'm negating the power because the x was in the denominator. Oops. Let me backtrack. This has a prime on it, but it shouldn't, right? All I'm doing is a series of rewrites, okay? So now I'm ready for the derivative. K prime of x equals 6/13. And now I'm going to do negative 2/7, x to the negative 2/7 minus 1. So now K prime of x